Okay, so this is a tutorial video demonstrating how to implement a PowerUp pickup in Unreal. This pickup will provide the player with a certain power-up that will last for a certain duration of time. The pickup's duration, power-up type, power-up strength, as well as its rarity is procedurally generated. The type of power-up available are speed, jump, and size. Starting off, I'm going to import a custom mesh that I made in Blender. You don't have to do this, you could also just use a typical cube, but I'm just doing this because, well, it looks nice. One class that we need from the lab activities is the pickup class, which we're going to be using to create the child class called PowerUp Pickup. Another thing we're going to do is to make a blueprint using PowerUp Pickup. After that, we're going to drag in the custom mesh we're using, or any standard shape, and we're going to make it so that it fits within the size of the pickup bounding box. We're also going to add a pickup rotator blueprint component to it and set the speed to 30. Once we place it into the world, it should spin and look like that. After that, we're going to go into PowerUp Pickup.h and we're going to set up the different enum types. The first set of enums we're going to do is PowerUp Pickup type, which is to determine the power-up type. We're going to have speed, jump, and size. The second set of enums we're going to do are power-up pickup rarity, which are the rarity of the pickup. Next, we're going to be adding some public functions, which are onPickup and onGenerate from the pickup class. We're also going to be adding in a private function, which is the generate random boolean array function from the lab activities. We're going to be using this function the same way we did in the lab activities, which is to set which stats are going to be good and which stats are going to be bad. We're also going to make a public function called setRarity, which returns an int32 and takes in an int32. We're going to be using that to set the rarity. Next, we're going to have two enums for power type as well as the rarity. Next, we're going to set up some variables which are used to store the stats for the power up, such as its duration, the player size, the jump height, as well as the movement speed. These variables are going to be used to change the player later on. We're also going to set each of these variables to uProperty visible anywhere blueprint read only, as we're going to be using them in a blueprint. Now we're going to be putting in an empty implementation of all of the functions. We're also going to be copying in the code for generate random boolean array. Next, we're going to be heading over to player character.h, where we're going to add some variables which are going to be used to store the default values for the player character's movement stats as well as its player size. This is done so that we can revert back to it after the duration of the power-up is finished. Going to be adding in a revert stats function as well, which is going to do the aforementioned, as well as a increase stats function, which is going to store a timer that calls reverse stats after the duration is over. We're also going to be adding in a fTimer handle, which is going to be used in the timer. For that, we're going to have to include timer manager.h. Next, we're just going to be putting in some empty implementations of increase stats as well as revert stats in the .cpp file. After that, we're going to be moving to the constructor and we're going to be setting each of the variables to be equal to the default values found within the character movement component in the player character. We'll also be storing the scale of the actor, which is the size of the character. After doing all of that, we're going to be going back to the PowerUp pickup.cpp file and setting up our onGenerate function. First, we're going to have two int32 values, which are possible numbers between 1 and 100. These values are going to be used to determine the PowerUp type as well as the rarity of the pickup. Now we're going to set up an if-else-if loop similar to the lab activities, which is going to be used to determine the PowerUp type of the pickup. On screen now is the different chances for the different power-ups. You can change these values to whatever you like. As seen at the start of the video, each of the pickups are going to be pointing in a different direction depending on the type of power-up it is. For example, jump is pointing upwards and size is pointing downwards. To do that, we're going to have to change the rotation of the object. To do that, we're going to be using set actor rotation within the if-else-if loop, and we're going to be setting it using an F rotator. We're going to be rotating it 90 degrees on the x-axis, depending on the direction we want it to be pointing to. We're going to compile that code, and we're going to be going into the event graph of the pickup blueprint and calling on generate on begin play. As seen here, this is a speed pickup, so it's pointing horizontally. After that, we're going to be doing the set rarity function, which has the chances of setting the rarity as shown on screen. We're going to be putting in the rand rarity value from earlier into set rarity, which will determine the rarity of the pickup. After it sets the rarity, it returns an int32 value, which is going to be used in the generate rand boolean array call. The returned int32 value will be used to determine how many stats within the PowerUp are actually good and how many are bad, just like in the lab activities. We'll also be needing a t-array of booleans to store the output of generate random boolean array. We're going to be using a ternary operator in order to set the duration as well as the PowerUp stat of the pickup. A ternary operation is a shorthand way of writing an if-else statement. If the boolean from the random boolean array is true, then we get the good values. If it is false, then we get the bad values. The range of good values and bad values are being shown on screen. For the player size, we want each of the axes to have the same amount of effect applied to them, so we don't get a misshapen character. So we're going to put the results of the ternary operation inside a float, and then we're going to put that float into the f vector for player size. The values for the minimum and maximum of the random range can be changed by you, depending on what you want. Currently, the values I've used are an upgrade to the player's existing movement, but aren't too extreme, so that the player can jump extremely high or move extremely fast. After we compile the code, we can check in-game and see that this particular size pickup has the following stats. As you can see, jump height and player speed aren't changed, only player size, which is exactly what we want. As you can see here, we have different materials for the rarity of the pickup, which we're going to implement now. We're going to be using the same method as we used in the lab activities to set the material, which is to get an equal enum blueprint and then use set material for the mesh. Here I've set up two rows of the pickups to easily see the differences between each pickup depending on its rarity and its power up type. As you can see, each pickup has a different size, different rarity, different duration, and different PowerUp stats. Next, we're going to go back into the blueprint and override the onPickup function. We're going to cast the actor that picked up the blueprint to a player character blueprint so that only players can pick up the blueprint. Of course, we can also implement this for enemy characters as well. After that, we're going to go back into player character.cpp as we implement the increase stats function. We're going to be setting up a timer, which after a certain duration, it will play revert stats, which will set the character's stats back to normal. We also have to set this timer to not repeat because we don't want it to constantly reset the player's stats. To revert the stat changes made by the pickup, we simply use the variables that we set with the default values at the beginning, and we're going to set the values inside the character movement component to be equal to those default values. Still inside the revert stats function, we're going to be implementing a line that will print a message on screen whenever the PowerUp has expired. Inside the PowerUp pickup blueprint, we're going to be making a call to increase stats, and then we're going to be putting in the PowerUp's duration. This will determine how long until revert stats is called and the character's movement values are reset to normal. As you can see in the top left, when the PowerUp has expired, then a message is printed. Now we're going to make a new function called setPlayerStats, which will set the player stats according to the values that were generated. We're going to be using a similar logic to the setMaterials function, where we use an =enum node to check the power type's enum, and then we set the stats accordingly. SetPlayerStats also requires an input value of a player character blueprint so that we can access the player character's movement component so that we can adjust its values using the values we've made using the onGenerate function. Firstly, we're going to use the setActor3D node. Firstly, we're going to use the setActorScale3D node to set the size of the player using the player size variable we had from earlier. Next, we're going to be setting the speed and then the jump height. As mentioned previously, we're going to access the character movement component inside the player character blueprint, and then we're going to be changing the max walk speed and the max jump height depending on the power type's value, as well as the player speed and the jump height variables we set earlier using onGenerate. Finishing off, we simply attach the setPlayerStats function to increase stats and have it end with destroyActor, and we plug in the player character blueprint cast and we simply play. As you can see, once I touch the rare speed power up, my movement speed is increased, but when it expires, my movement speed is set back to normal, which is slower. For the size power up, you can physically see that the camera gets lowered, and if we press the semicolon key on the keyboard, we can see that the character model is in fact smaller. For the jump power up, I can now jump and look over this wall, whereas previously I could not. And that's it for the tutorial. Now onto the project cohesion and plan. In terms of cohesion, my teammate and I have implemented several changes to the AI which give them an advantage over the player. They can detect the player through hearing and sight as well as jump over ledges. However, these power-up pickups that have been implemented will provide the players with an edge over the AI enemies. In terms of the scope, only simple and small additions have been made to the project, which are all within our skill level, in order to prevent scope creep and the inability to complete our plans. For Assessment 4, we're going to be making it so that defeated enemies will be dropping power-up pickups. In addition to that, we'll be adding a HUD element which will display a health bar as well as a duration bar for the duration of the power-up. In terms of changes to the project for multiplayer, we understand that the pickup will now have to be generated on the server, which includes its stats, as well as the HUD elements will now have to be updated using rep notify. Okay, well, that's it for the video. Thanks for watching.